That way you can actually see my desk. I have a peripheral, whatever you want to call it, of tools here. But before we get to any of that, let's actually look at what you're going to need. What we're kind of building, actually, not what we need. We'll get to that in a second. So this is one that I've already built. It uses the same cells that we're going to be using today. Here's one of the cells. This is a lithium iron phosphate 25 amp hour battery and 3.2 volts each. You don't want to arc these out with anything. They're very powerful. They'll do easily 25 or about 50 amp hours or 50 amps, if not more. They're rated up to 50 amps concurrently, but they're some pretty serious batteries, especially for the size. So, this battery pack right here, with each one of those being 25 amp hours, there's 4 of them in series, giving us a around 14 to 15 volt battery pack at 25 amp hours. I have 2 charge ports up on the top. The yellow one's for charging it. Typically you use a charger that looks similar to this right here. This particular charger will charge 14.6 volts at 8 amps. So you can plug it in right like here, and then plug it into the wall, and that's how you're going to charge it. These typically run about 25 to 30 bucks depending on the day, and they do make bigger ones that can do more than 8 amp hours. You can get them all the way up to about 20 amp hours, then you have to look into specialty equipment to charge this type of stuff if it's more than that. Alright, so that's that. Something like this is really great because you can swap out cells if the cell gets damaged. You know what's in your battery. You're not, a lot of these Chinese batteries, you don't know what type of cells they are. You also don't know the quality of the cell that they're putting in them. I'll crack this thing open. On this particular one, you'll notice this screen right here. This is known as a battery colorimeter, I believe. I don't know how to pronounce it correctly, but basically it's a screen that will tell you your percentage left on the battery, and it'll also tell you how many amps you're pulling, how many watts, how many amp hours you have left. It's a really good way of seeing your status of your battery, and this thing uses like very little power, so I'm not worried about it draining. If I was to revisit this, I'd actually put like a turn on and off switch to disable this and its output, maybe using a relay or something. Looking inside, it's kind of a mess. I did this about a week ago, so it's not perfect, but it's not great. So everything's up in the lid. It's kind of hard to see in this right here. So everything's up in the lid. Here's the cells. They look teal in the camera. They're actually blue. Here's a 30 amp fuse. I actually don't plan to use more than 30 amps on this. Right to the BMS. The BMS is going to provide protections against overcurrent, over voltage. You guys need more volume? Alright, we'll push more volume. There you go. So, with this protecting the battery, so you don't overcurrent it, over voltage it, overcharge it, and things like that. And then on the side right here, which is kind of hard to see, is the current shunt. It's a device that is used to measure the amount of flow of electrons going to your colorimeter. That's going to tell you what your voltage is and how many amps you're pulling. Okay, so with that said, let's actually build one. Now, let's talk about parts that you'll need. First things. Oh, and by the way, you can charge these off solar panels. This right here is a 30. I think it's a 30 watt solar panel. This will put about 2.25 amps out at 12 volts to charge this in direct sunlight. So that's an option. And they make charger controllers that look like this, and other ones as well, that you can easily modify and hook up. So there's many different ways to charge these bad boys and so on. One thing I want to mention, since we were talking about preparing, is let's say you need to use a radio. You can easily plug it into Anderson's. The other thing that I have right here, which is kind of cool, which I got in Montana, which is nice. This guy here is an actual stove for like cooking food for like truck drivers, and I've modified this to not be we call it standard cigarette lighter, but to Anderson's. And so all I have to do is just plug this in like this, and this battery will come alive, like it just did. And this thing's now heating, as you can see. This thing will get up to 300 degrees, and this thing will run it for about 2.5 hours, roughly, depending on what you're trying to cook. You know, depends on heat and all that fun stuff. So something that you know, is this small, which doesn't weigh much. I can, you know, lift it with my you know, pinky. I can run this you know, 10 amp hour, you know, heater for 2.5 hours. Something to think about, especially weight savings. When I was talking on a VHF 50 watt radio, I think it said I could talk for about 4.5 hours before the battery would die. So, good little guy. Yeah, we're gonna build its Big Daddy, which is going to be 4 times this. So this is a you know, 12 volt battery. Let's just call it 12 volts at 25 amp hours. We're gonna quadruple that. All right, so let's go into what you need for parts. There we go. All right, so tools. Okay, normal stuff. If you're doing power poles, you need a pair of crimpers for power poles. I have some crimpable power poles up there. Just basic flush cutters are nice to have. Some, you know, ways of stripping stuff, whether you're using you know, feed through and strip, or if you're using these type, they both will work for this. These batteries, you have to link them. So you have to positive, negative, negative. So you need bus bars. This right here is copper bar material. It's an 1/8 inch thick, and it's about, I want to say 20 inches long. We'll be using a couple of these. I actually have plenty of them for this. We'll use this, and you're going to need a way of cutting them. I find mostly that these just work. These are normal tin snips. It's copper after all, and it doesn't take much. So, and other type of batteries that you guys are probably used to, by the way, are like lead acid. This is only, what is this, 7 amp hours? It's basically the same weight as a 25 amp hour. So just giving you guys a little idea of that. The other thing you'll need, potentially, is some heat shrink, a way of heat shrinking things. So that will work. When we're doing these type of batteries, you can't use electrical tape. So what you normally use, this stuff made out of polyvinyl chloride, or I really don't know at this point what they make these out of. Just normal electrical tape. You don't use this particularly. And the reason for that is this stuff burns. For instance, if I was to take a little bit of this and light it on fire, it burns pretty good. You don't want that in your battery, because if that happens, you risk, well, it burning, especially if it goes into a thermal runaway. So you want something better than that. And for that, we have something called Kapton tape. We use these in batteries, and we also use it in 3D printers for the bed, because it resists, it doesn't like burn. I'll pull a little bit off of this to show you kind of how it works under flame. But it's kind of a cool material. It's kind of translucent, but the key point is it does not burn. Oh, okay, you really got to burn it. But nevertheless, it's not going to burn, allegedly. So, wow, that really got hot to burn. Okay, it's weird. Okay, the other thing you're going to need for all this, some drill bits to drill the bus bar out. You're going to cut the bus bar to size, measure, make some marks, and then I'll drill some holes. The other thing we're going to need is the BMS. Now, there's some smaller BMSs. This is an old one I have. Just a 4S BMS. You can find these on eBay for around $30. This one will do 60 amps of current in a 4S configuration. So you can run up to 60 amps of power through it before it'll either trip or it just won't handle it. I want to be able to put the full 100 amps out of this. So we're going to use a bigger one. I present to you this one, which is 100 amp hour. They go all the way up to about 200 or 400 amps. So big heat sink on this one, and a lot more rigid on this battery pack, or this BMS. So, and then up here we have, what do you call these, some washers, and then you gotta have your nuts. Lots of nuts. And I did bring the tool to torque things down. We'll have to come back to that. Alright, so, and you need a good voltmeter. When you're putting these cells together, you need to make sure they're all the same voltage, no differentials, because you might, say you have one cell that's half a volt too low than the other ones. When it goes in, it's going to try to transfer its power over, and you might overload it by introducing too much power from one battery to the other. So you want them all to be the same. Alright, let's get what we don't need off the table. Sweet. Alright, so let's get a building something. Let's make this a little bit cleaner. And a lot of stuff I don't need right now. We'll leave that there. Yeah, I need this right now. That can all go there. Man, my room smells like burnt candles. Weird. And a drill, of course, which will just sit there. Alright. Here's the fun part. Let's go play with batteries. Note that these batteries are open top. The stinger, or the bolts, both have power, negative and positive. The other thing to note is a lot of these cases, the metal in the case, also has a voltage potential on it. So even this middle portion right here has voltage potential. So you don't want to arc this to the case, or both of them together, or just be careful. The other thing is in the center right here, I don't know if you can see that very well on this camera, that is a vent. So if this thing ever had to release pressure or equalize its pressure, that vent's there to help that happen. So again, we're doing 4S and 4P, meaning 4 of these batteries are going to be in series, and 4 of them are going to be in parallel. And so the easiest way to do that is we're going to put them all in the same orientation, like this. We're going to tilt it like this, and all these line up. And then the next one, as you can see like this, we're just going to, gotta be careful. All these things are relatively safe. You don't want to jar them like I just did, because, man, it'd be a bad day if one of these had a problem. But we're going to put into that, and we're going to link the rails up, basically, which will give us our battery. And furthermore, we're also going to rotate them like this. And then the next one, because the way I'm going to put them into a case, I'm going to put it like so. So I'm going to offset them. Oops. Just like that. So, going from down over here, this whole side would be one, and then this side to this side, and then this side will be one, and then you'll have your positive, your negative, and you'll have a bus bar going across right here, which you can't see, or from here to here. So, it'll make more sense when we get to it. And then, either on the back or the front, we'll put the BMS. Okay, so we need to measure bus bar and start cutting it and getting it ready. So let's get half of these gone, because now that you see what the battery's going to look like in this configuration, let's actually make it safer, which is less batteries, or less cells, I should say. Now typically I wouldn't move these batteries as much as I am, but because I'm trying to give you guys the best view of how to do this, it's kind of needed. So, the first thing we need to do is, so, here's the, hold on a second. Which one's positive, which one's negative? On these particular batteries, some of them are marked. Okay, so these are negative, so the silver ones are positive, and the we call these brass ones are negative. There's a little mark that says it's negative, and then this one has a positive mark on it. So by putting these in like this, or this bus bar on this side like that, we basically make kind of a battery that's all one. So we would have to do this, and then we would have to put one here, and we would have to put one here, but put a split right here. So let's measure and start cutting. So I also have a caliper that will help us make some measurements. So I want to, on this first one, measure from the center point right here, roughly, to about right there. So that gives us 96 millimeters between this portion to this point in here, which we'll also use to make a point for here, and then this one will be one long one. Okay? So let's just take that and lay it down on our copper, and we really should have something to mark this with, but we'll just use a screw. There we go. And we'll make the next mark, just like so. And then this is where you're going to take your tin snips, and you're just going to cut it, just like so. There's one, and here's number 2. Alright, we're going to need some more of these. For this particular battery, we need about 4 of these. So let's mark them. This is for the other side. I'm pretty sure we need 4 of them. I could be wrong, but typically not. I'll just mark it with a razor blade. It's kind of hard to see what I'm doing over here. So there we are. Just go and mark it. And then find the next one. And mark. Alright, cool. What will be the final weight of this battery? So, when I ordered these cells was, I think, 36 pounds or so. I'd have to go back and look. I know it's about like 1.2 pounds per battery. So with 16 of them, times that by 1.2, I have to do the math on that. So 16. Okay, I'll just do the calculator out. It's easier that way. 1 second. 16 times 1.2. So you're looking at about 19, 20 pounds, somewhere in there, for this battery. Actually, I think it's a little bit more. I think it was about 25 pounds, actually, is what I came up to. I think it was like, yeah, I think it was about 25 pounds. So with everything in the case, 25, 26 pounds. So 100 amp hours is the total weight this should be. Okay, so let's cut these ones. And let's just speed this up, because I know you guys don't want to wait all night for me to build a battery. Okay, cool. Alright. I'll just save that for later. So these will become the links between these cells and, say, these cells. Now we still need a whole bar across this, and that will give us positive, negative, and then this will link the 4 cells together. Alright, so let's get to that. I think these are the right size. Let me double check one last time. And okay. It's going to be fun to do some drilling with that. Alright, the next part is one big giant linking right here. And I'm just going to eyeball it because it's not going to hurt anything. And I want to say both are the same roughly. It shouldn't be a problem. There's one. Again, you can make this way more intricate and better. You can even deburr the edges. But there's your bus bars. Okay, now we just need to drill them. That's going to be the fun part. So, let me get my drill bits out. And we'll start small and work our way up big. I think it was 5/16 last time, or maybe it was 1/4. But I'm pretty sure it's 5/16. We'll see. So there's our bits. There's our pre-drill, and here's my drill. Okay. This goes a lot easier if you have a what's it called? A permanent marker, which I forgot mine evidently. Okay. Well, I should have brought a permanent marker, but I didn't. So we'll just do it the good old-fashioned way, and we'll just measure tip by tip on the cell. So center of one cell to the other on this. So about 27.3 millimeter. So we'll just stick it right there. 27.3. I really should mark this. We'll just mark it like this. This is the hardest part. If you had a better way of doing this, it'd probably go a lot easier. But I only have what I have. And this is the tedious part, is doing the layout for all this stuff. Wish I had actually had a, what do you call those punches that they use? That's good enough though. And then the last one. Let's keep our number at 27.3, please. And something like, oops, come on, 27.3. Close enough. 27.4. Okay. There we go. And let's pre-drill those. So, stick that in. Drill. And then drill again. Lock that bit. And one more. And I didn't charge this drill. So there's a good chance I won't be able to finish this project tonight. Alright. Let's see if these lines match up. And ooh, that was off by a lot. I think we still good though. So we'll go with this one. So let's drill this all the way out. That's hot. That's nice. There's one. Yeah, that's way too hot. Now let's put it down over here and do it. Nice and hot. Really need strips or something. Whew. Nice and hot. Alright, lay that up. And yes, that will work. I'll let that cool for a second. Any questions for people watching? Yeah, I can't believe I didn't charge my drill. Down to 1 bar. Good old Milwaukee. I have another one here somewhere. Or it might be on my truck. Alright, that should be cool. All in all, it's just a little bit of copper. The copper is great for heat. Ah, yeah, that's great. Drilling! Alright, so the last part. That's hard. Let's do it over here. Alright. So it's not perfect, and to tell you the truth, I'm actually just going to trim these edges just a hair. I don't want them sharp. Don't want any dark spots. I really should invest in a nice deburring tool. I guess I can use a razor blade. But the other thing you need to worry about is having all this shaving stuff near your batteries. I'll probably clean that up in a second. That's never fun to have near your batteries. Alright. That's not too bad. That's good. Alright, let's split these apart. Put them over here. And let's just segregate these ones for a second. Now I should be able to just drop this on. And yeah, that's going to work. Okay, cool. Now, I can link these together. I can just about link these ones together, but I don't want to yet because I need to check polarity, or not polarity, but voltage. So as long as all of them are negative, and I put this bus bar on, it's not going to connect them together and start charging each other if one's lower than the other. So this is where having a voltmeter, and we're not talking about the cheap Harbor Freight ones, we're talking about one that can actually measure like point of a volt. Oh, this thing has a crack in it. Nice. When did that happen? So here's my voltmeter. I don't know if you can see that. So this will do, what is that? Volt, tenth of a volt, 100,000th of a volt, I guess. I could be wrong. But you want to double check all these, make sure positive is positive, negative, negative. That's 3.289. This one, 3.291, close enough. 91 and 92. Okay, so they're within, you know, 100th roughly or so, or 110th or whatever of a volt between each cell. As long as they're not more than like, I'd say like 0.1 roughly, 0.2, somewhere in there of a volt, you're not going to have much problem with these cross-charging and overloading each other. Alright, so that's that part. Let's put this together. So we're just going to drop this bus bar nice and safely on here, just like so. Okay, and then we're going to place a washer down on that, because we do want that to be nice and neat on each one of these. And this is literally how you do it. I mean, it doesn't take rocket science. It's just you linking batteries together using bus bars. And we'll put another nut over here. Now do take note that now that you've added this bus bar, this side's connected, so you could put another bus bar over here, and then you'd have a 4P1S, or I'm sorry, a 4P1S, so 4 in parallel, or this would be your parallel. But we're going to add another series over here, but our negative is going to start over here, and so you'll have 2 in parallel, but 4S. I'm sorry, 4 parallel, 2 non-parallel. Would that be a series? So we're going to put our nuts on real nice. Alright. Do a good little tighten. Now, at this point, it's semi-rugged. We're going to make it a little bit more. Let's clear up some of this. And I actually kind of want to link these a little bit better at the bottom down here. And for that, we're going to use our good old Kapton tape. Again, this stuff's supposed to be fire resistant, or high temp resistant tape. I guess it does burn. I guess anything burns if you put enough blowtorch to it. So we're just going to peel this back and wrap the bottom so they're kind of one at this point. Just like this. Alright. Just make it real nice. And then we'll rotate it. Alright. I think we'll make this into maybe a 2-part series, because There's a few things I forgot, like the tool to actually make everything screw down on it for these bolts. But as you can see right here, we have these 4 cells connected via a bus bar, and we'll do the same thing on this side, but let me rotate this way. So if this makes sense to you, we'll have one of these longer bus bars on this side. I'm just going to, yeah, let's not do that. It's just going to fall off. So there'll be one on here, and then we'll put another small one right over here on this side, and there'll be a little hole right here between this and this. And this would then become your negative and your positive, and this would be in a 2S configuration. Okay? Once we get this made, and we have the other side built, we'll then take one of the tops of the negative, and we'll bring it over to the other side, which will be the positive, with a linking bar that we'll have to do a little bend work on, and that will be our other side. So I think my drill has enough power to do one more of these, or maybe one of these. I'm not quite sure, actually. It's down to its last bar. I really should have charged it. But we're basically going to do this again, but on this side, and we're also going to add this one on this side. So basically the same thing. But I'm thinking let's do that to next week. So I'll do that part, and then when we come back next week, we'll do this part. Well, this part will be done, and the other part we'll link the two together, and then we'll show you how to connect to the BMS, which is not that hard. You know, with all these wires, you think, oh, you know, this is a lot of work. It's really not. It's just basically taking your battery negative, finding your battery negative, which will be this right here, putting this on, and then you can either tape this with like double-sided sticky tape right here, and you just link it in, and it becomes a battery at that point. It's becoming a battery right now, but the main difference is we don't have this linked, and right now we just have 4 cells in parallel, not series, where a series is a battery, parallel, it's not so much. So, yeah, any questions before I guess close this down, because I need to charge my drill, which I totally should have done before I did this. Yeah, any questions? I'll wait for a couple minutes for the chat to catch up. But, yeah, I mean, it's not that hard. Busing, it's pretty simple. You can oversize the holes that you're drilling, so you don't have any like fumble play, or you have some fumble play, and then you just use washers to really make sure the holes fit and everything. So yeah. So yeah, next time on the next video, I'll have this long bus bar, like I said, in, and then we'll have another short over here, and I'll make the other set, the other series. And when you do the taping on this portion, you tape like 4 together, and then your other 4 together, and then you'll just tape everything together to keep it together. Even though the bus bar will help on this side, it doesn't hurt to have extra stability. And then, like I said, once I build both of these up, you'll see the configuration, and you now understand how to do this, and you can do that. And then when we go to do the BMS, we'll actually just attach right onto this, and it'll get distance wires. Alright, well, this is Kilo 9, Romeo Charlie Papa, and this is a battery that we're building, and we'll see you next week, or maybe we'll do it on Thursday, right after the mesh net. Alright, that's all I got for you guys. Have a fun night, and 7 threes.